going live here on the HVAC School Wednesday live stream that we do once a week. Thank you everybody for joining us. Today we have Tim Destasio, former contractor, now trainer, educator, designer out of North Carolina, and my new friend Brynn Cooksey out of Michigan. Same thing, contractor, educator. And for today's topic, I'm really excited about this. We were kind of thinking through because we talk a lot about like the ACA manuals and the designs and all that stuff. And it's good sometimes to actually just get really practical. So we've got a problem, we want to solve it, and we need to use design and design thinking to solve those problems. So I think it was Matt. I think Matt, you came up with this topic, right?
Yeah. And actually, Tim, I thought I would start with you. Talk us a little bit through. You just built a house. Talk us through some of the questions and I guess some of the trade-offs that you had to make. Some of the things you were thinking through when you started designing your house. It could be a good place to start.
Well, I was inspired by Corbett Lunsford building a really high performance house, and then when I started pricing how much that would cost me, I decided that I would just build a pretty good house. And so
do you have that book?
I've not read it yet. No, I was I heard there's a book about that, and I do not own it. Short answer.
Okay, I just got it in 2 days ago, so it's just funny that you brought that up. So anyway,
we were having a lot of conversations with like Dr. Bales and a lot of other people, just trying to figure out where the compromises would be. And then I just started running simulations on my load calculation software and just started seeing, okay, well, what if I made the walls 2x6? What if I made the windows really high performance? Like, what would give me the biggest bang for the buck? And at the end of the day, in my climate, the biggest thing I need to be worried about was air sealing. And so I decided to go with zip system sheathing and spray foam insulation and really put the time and the anal retentiveness into air sealing my house. And I ended up getting a really tight envelope and I ended up having a really aggressively sized system. So, but one of the surprises was I had walked through this house. This was a house that builder builds his plan all the time. He's a pretty good builder, but he's not a high performance builder. He just builds a quality house. Originally, the unit was supposed to be one place in my encapsulated attic, and I kind of designed for that. Well, when they actually framed the house, it turns out that the unit could not go there. And so I had to make some pretty major changes, which included making my return trunk, instead of just a nice short trunk, into an open area return and jumper ducts everywhere. That's what I wanted, keep my friction rate low. I ended up having to run a return trunk pretty much across the house and then split off of that into smaller returns for the rooms. And it made my friction rate a lot higher. But what I realized is after modeling that in the software, it didn't really change my duct size that much. And that got me thinking about, well, I've been teaching people all about design, and you've got to get things just right. And at the end of the day, I still ran a 14-inch duct to my return after all those changes. And so being pragmatic and knowing where the big drivers of your manual J, manual D are, and trying to find ways to streamline that process, I think is really important. And knowing where you can compromise, what the big movers of your load are. It's not windows, unless you just have like a complete wall of west-facing or south-facing glass. It's not a lot of the traditional things that we think it is. It's not even wall insulation. Once you get past a certain insulation level, there are diminishing gains. And so where do we put our budget? And it really goes back into things that involve craftsmanship, duct sealing, air sealing, making sure the system is sized aggressively, know what your humidification, dehumidification loads are. Those are the things that really matter. Not to throw shade on all the other stuff. I don't want Ed Johnwalk to clutch his pearls as I say this, but there are certain things that just don't move the needle as far as maybe we think they did.
Yeah, that's really good. Brynn, I saw you kind of nodding throughout that. What did that kind of stir up for you?
Ditto, and pretty much everything Tim said. We're in a little cooler climate, So attic insulation is a big driver for us. And also air sealing. So air sealing is one of the most important things we do. The BTU savings, especially when it's cold outside, and then also the amount of moisture that comes in that can ruin the actual physical structure. So I agree with Tim. We do a blower door test just about with every load we come across, and sticking that infiltration into our software, we see that needle move quite a bit, especially this older leaky housing stock we have in Detroit. So what Tim said, I agree with wholeheartedly.
And you gave us a couple slides. Can you walk through this particular this trunk system and kind of what you did with this?
Yep. So back in 2021, we was like, okay, as a company, our contracting business, we knew it for years, and we just kind of went in with the assumption, and we just said, all right, let's actually track it. So out of about 3,800 homes, we kind of found out that in our local area, and I hear this is the case across the country, that the equipment is kind of grossly oversized and the ducts are grossly undersized. So this was like a 16 by 8 connected to like 120,000 BTU furnace. And that's something we walk into like every day. And the static pressure's through the roof, and there's a lot of complaints and stuff like that. And as you see, it's relatively small once we compare it to the next picture, and it's also unsealed. So when we did the furnace mod, look how much larger that duct system is, and immediately the customer's bills were lower. And the customer even revealed to us that the second floor, which was typically uncomfortable, was a lot cooler as we started to get warmer here in Michigan the last couple of weeks. So the whole design process, you can focus on changing parts, but if you get the design process correct, that equipment is going to have some longevity, especially low calc and ductwork and balancing.
One of the things you had talked about, I'm going to give away some stuff we talked about on the podcast. By the way, when Brynn's podcast comes out, listen to it because it was amazing. Tim's as well. They were both amazing. But one of the things you talked about was every time you have a system that has poor ductwork or poor airflow, you immediately inspect the heat exchangers. Just talk about that quickly and kind of what you found in that.
Yep. So if you look at what kills the heat exchanger, is typically improper venting. A lot of times it's poor airflow. So you look at high temperature rise or high static, and we look at it. And then with the assumption that we have here in Michigan that everything is grossly oversized. Once we get into a situation, once we measure static pressure or temp rise, and we see that those are off the chart, we take the time to get into the equipment. So we'll pull the blower motor out physically. The techs will get in there and actually look from the bottom to see if they have any kind of cracks or anything like that. And we find them, I'll say 90% of the time, they're physical giant cracks that you might have couldn't see maybe from sticking an inspection camera through a limit or looking at it from the top. But if we pull a blower motor out, we typically find them with neglect and high airflow, poor airflow situations.
Which is kind of exactly what we're talking about here. It's like you can be theoretical about this stuff all day long, but when rubber meets the road, where you're having cracked heat exchangers because you have such poor airflow due to, like you said, both oversizing and poor size ductwork, it's like a toxic mix of both. It really does have physical impacts, and obviously, there's the whole cracked heat exchanger debate. But regardless, if you've got physical cracks in your heat exchanger, that's something you need to address. Everybody knows that.
So, and how difficult is it to go back in and do something like you did here? Like, yeah.
It depends. So if the load is so far out the way, usually a major duct mod is required. In this situation, we had to pull all the ducts down and then start from scratch. If the load, after we properly size the equipment, sometimes the ductwork is now properly sized. It happens. So in that situation, we do a small duct mod. Maybe we'll move some supplies, different spots, make sure it's balanced correctly. So it depends on the situation. Sometimes it's a full gut mat. Sometimes it's a small duct mod. Sometimes it's not a duct mod. We're actually able to seal the duct system because the static pressure is lower. So it just kind of depends on what situation we're in.
Gotcha. Yeah, Adam, I know you're in a similar market. Like, what do you see? What are your thoughts on?
I mean, it's always oversized. I would say at least 9 out of 10 times that we replace equipment, we're replacing it with smaller equipment, whether that be furnace, air, or heat pump, whatever. And ductwork is usually undersized, but a lot of times it's fairly close when you size the equipment properly. And I say that sometimes you still end up with kind of high static in my experience. And this is like selecting a larger media filter and maybe hand picking an evaporator coil, so you have lower pressure drop. So we still kind of ride that higher edge, but that's like, I'd say most of the time around here, people have finished basements and that, so they're not going to want to rip down drywall and that. So it's like we do the best we can with whatever like near equipment modifications we could do, So.
Yeah, I think that's a really good point, is just trying to figure out, kind of find that line between, what you can do and what's not, really feasible. So what do you guys think are some of the maybe the biggest challenges to doing the things that you would really want to do with design on a house? Some of the biggest limitations.
I know when I talk to contractors and I train techs, a lot of times they may skip that process because of the time. They feel like it's a lot of time involved, especially from a sales perspective as a contractor, providing consultations and stuff like that. To go into this level of detail does take time. So some are fearful of investing the time into this type of situation and maybe not seeing a return for it. So you'll see some who may have the knowledge, but they're afraid of investing that time. So I see that's a challenge. What helped us in our business is getting kind of quick processes down. We can get a lot of information really quick to make decisions. So if you're able to process it, it's process driven, you can save a lot of time.
I think go ahead, Tim.
No, go ahead, Adam. That's fine.
I was gonna say, like, I've kind of worked on, smaller homes, smaller residential homes, all the way up to like larger custom, just like everything is one-off type deals, and a lot of times when we're designing or installing a new duct system, I struggle with trying to locate the equipment where I'd like it to go, run the ducts where they're most, convenient and where it's going to work the best for the system. And then also a big one is, because we have a lot of floor registers, everyone wants to go with those hardwood floor registers, right? And I never want to use those. I always try to recommend a higher end register, and they most of the time shoot me down. So that's like a huge struggle that I face.
Right.
And I'll speak to that from a designer standpoint. I'm finding a lot of challenges with newer homes that get designed by a fancy architect. And man, it's a beautiful looking home. It's a beautiful set of drawings. He just didn't give us any place to put ducts. These homes, they're not built with a full basement. And a lot of the ceilings are vaulted ceilings, so there's no attic space. And I just want to slap him around and say, what were you thinking? Like, how would you like for me to get from here to there? How would you do it? And so it's very challenging. So then you start talking about drop soffits and all kinds of crazy stuff. And architects are just like, well, I carved you out a little space over here. It's like big enough for an 8-inch duct. Or, I'm working on a house right now and they have a beautiful glass on 3 sides, living room, dining room area. It's all glass. I mean, I'm way too judgmental to live in a glass house. So I don't know what anybody is wanting to live in a glass house for, but it's like a greenhouse. And so you're trying to figure out where to get ducts, and the ducts are huge. And it's being put in a corner that you have to now, you just say, look, this is not possible. It's not, the laws of physics do not allow this. And putting your foot down. I think a lot of contractors, allow themselves to get bullied in a sense, and the client, the customer, the builder, whoever it is just trying to make them do impossible things, and then they start compromising on duct sizes, on unit sizes, even again, like Brynn, what you were saying, being very rushed through the sales process. We create this environment where it's just rush, go, 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 and we end up cutting corners. And who's the one that ends up paying the price? It's us. We end up getting callbacks. We end up having to fix these problems now for free because we didn't put our foot down on the front end, or we didn't establish processes on the front end. Let's take this for example. All right, we got a 2-ton system. Let's say now in my house I had a heat pump. Let's say I decided to put a gas furnace in there. 2-ton system, nominal CFM is 800. All right, so I could have put a coil in there, that 2417 coil with a pressure drop of 0.25. That would have matched up just well. Just fine. But look at that pressure drop, 0.25. There's no way you're ever going to run 0.5, 0.6 total static pressure. You're going to be running really close. And I'd be interested, Brynn and Adam, what static pressures that your systems end up running with the challenges that y'all face. But if we would just find a coil that matched up, we could find that 3117. It's a 2.5-ton coil. It matches with the 2-ton. We'll probably pick up half a SEER that way. And now, to me, that is the matchup that I start selling. I do not sell a 2417 coil on a 2-ton system. I only do the 3117. Now, I don't have to match coils every other time. I know that's the highest performing system I can go. If I got static pressure problems, I know it ain't the coil.
And just a side note on this too, when somebody actually installs, like let's say you design a system for another contractor and they install what you spec'd, right? And their installers don't actually commission it properly. Let's say you did choose a 2417 coil. Now, if your design CFM is 800, that's a 0.25 pressure drop. Now, let's say they didn't commission it and they're running 1,000 CFM. Now it's up to 0.38, and it screws with the sensible heat ratio and everything else. So there's like so many pieces
on it.
Yeah, there's so many pieces of the puzzle. Like everyone has to do their job properly for a system to work out well.
Yeah, I think this is a great slide. Like this is problem solving design right here in a slide. This is the exciting slide right here.
This right here is the action. Look at all those numbers. Isn't that nice? Circles that are blue. Yeah. It's got everything going for it.
Yeah.
I wanted to add in quickly that like we're talking about two different things here, and I always like to make sure that we're clear. One is what you can do if you can design things from scratch, right? And at that point, the barrier is your architect, your contractor, your client, right? Those are problems worth solving. I just got back from Seattle where I spoke at a Passive House conference, and you want to talk about a bunch of nerds, boy, that was something else. And hippie nerds too. It was crazy. They had chickens at the hotel. It was weird. They served a roast beef at lunch. I thought everybody's heads were going to explode. It was like half the conference was just telling us we shouldn't eat meat. Anyway, I was making fun of them. They were great. They were great people. But anyway, so I did the presentation that I did with Kimberly before, the unicorns presentation, which is a lot about this stuff we're talking about. The challenges that we have with designers and all that. But one of the ladies who came up is a contractor up there, and she talked about, whenever she's designing a home, one of the first things she thinks about, and she's a contractor, is putting the mechanical room in the center of the home, having a home that's not unreasonably large, and having space for ductwork. And I was like, we need somebody like this in Florida. Like, it's just amazing stuff. And it was the same thing even in building my dad's house. My sister-in-law's a designer. She designed my dad's house. I designed it with direct returns going into an air handler and two gigantic, enormous Neil Comparetto direct returns with 2-inch filter racks. And the first thing she said when she saw what we did is she's like, "That looks hideous. You walk right in the door and you see those gigantic grills sitting right there." And I was like, non-negotiable. And that system runs 0.1 extra. It's infinity, and it's 0.1 external static is what it shows on the display. But again, like that's super cheap way of doing it, and all you got to do is get people convinced that it's okay to see a grill. Like it's not that big of a deal. But a lot of these things on the new construction side are just about overcoming design barriers where, like what you're talking about here, you're doing a retrofit, you're doing a change out. A lot of times those challenges are either about you making better selections, like you pointed out, or like Brynn was talking about, getting systems right sized and then really looking at and taking the ductwork super seriously.
Yep.
Yeah.
There,
go ahead.
I was just going to say, there's a couple, like in the retrofit situations, like Bryan was just talking about. Obviously, there's only a few things that you could change, like near the equipment. There's the takeoffs, like the plenum starters. You have your return drop, the boot for the return drop, and I'm talking like basements. I know you guys are Texas and Florida. You're like, what the heck is a return drop? That's what we have here in the Midwest.
Must be nice to be able to just walk up to your furnace and work on it. Not have to just fight a raccoon and a possum to get to it.
But you could change the coil and you could change the filter, right? But there's a few like things that I just look for as far as red flags. If you're going to design, like you're changing out a system and you're actually kind of looking at the design of what you're doing, right? So I just use as a real rough and dirty rule of thumb, ACA has limits for their velocities, right? It's 900 feet per minute on the supply and 700 feet per minute on the return. So if you're just looking at the return drop, calculate your velocity and see what your velocity is running. If it's over 700, it's probably too small. You need a bigger return, right? Another one is, what was I going to say? I had one. Now I've lost my train of thought.
It had something to do with magic and air conditioning.
One other thing is like, all right, so everyone uses a ductulator, right? It's the wheel that everyone lines up to 0.1, right?
Yeah,
that's like how most people design their ducts.
Yep.
So if you're like questioning if ducts are sized right and you have a system that's running high static pressure, one of the things I like to do, like if it's a original system for the house, if it's a 4-ton system, I say, okay, I'm going to line up 1600 CFM with 0.1 on my ductulator. What size duct would they use? And most of the time, that's what duct is in the house. And I'm not saying that's always wrong, because sometimes you will use a 0.1 friction rate, but most of the time, it's probably something's off on it, right?
So it just shows you that that's how they designed it, and so it's probably not right. Okay, I get what you're saying.
Just to dig in a little deeper.
Yeah.
I like it.
So I have some slides. I thought this might be kind of fun to show and then get you guys to kind of riff on it. This is my friend's house. He had the AC on the second floor and a chase running down and then ducts under the house. All of the ductwork upstairs was in this like triangle area where there was no access. Then the unit was in this upstairs closet. It went up and then it goes down and under. And so I couldn't see where the ductwork was at all. So this is what it ended up looking like at the end. This was my design. So like once I cut a hole in the wall and then I crawled back there and was able to access the ductwork. It needed to be zoned. So what I did was the airflow, I didn't want to put 2 units in the house because they were on a budget. And I had to redo all the ductwork under the house because it had been crawled over and smashed and broken and was full of water because they had a crawl space flood issue. So I had kind of a minimum airflow requirement for the upstairs zone of 30% of the system, which the rooms were only calling for 150 CFM per room. So I added a dump zone at the top of the stairs. It would open on static pressure. And that was my relief. That was essentially my extra air relief. And it just dumped it upstairs, which is great because the entire upstairs is just a sheetrock box with no insulation. So yeah, I think, for me thinking through this one, I was thinking about obviously budget. Duct location was big, not knowing where things were going to go. Because I didn't get behind the wall until I had actually started. And then using some new stuff. I had never used one of these rectangular trunk dampers before. It's just not a thing here. I've never seen one of those. So anyway, yeah, I had to think a lot. Like even under the house, I wanted to run a big trunk and have ducts come off of it, but there just wasn't enough space under, so I ended up having to run a lot of flex just because it's a smaller diameter. So yeah, I'd love to just kind of hear y'all's thoughts on that and anything it kind of sparks for you.
Tim's raising his hand. Let's go with Tim.
I don't know whether we're supposed to raise our hands or not.
Yeah, that's fine. It's better than raising someone else's hand. That would be weird.
So this is one of those classic cases where if you don't have software and you're just winging this, there is no telling what your airflow, what your static pressure is going to be at the end of this job. So if you can model that in software, we only have a couple of choices when it comes to legit ACA approved software where you can draw ducts. And so if you're listening to this, get one of them. One of them is really, really cool, and one of them feels like you're in 1995. So if you're my age, 40 or older, you may be okay with the older one because it kind of is a little retro. If you're over 40 or if you're under 40, then you're not going to want the one that feels like 1990s, trust me. But both of them will do the job. And it's crazy because like when you're trying to snake ducts from point A to point B, there's nothing you can do about your run out length. That is pretty much locked in. Maybe you can find a place to cut a few feet out, but I'm going to tell you a couple of feet is not going to make any significant difference in your friction rate enough to change a duct size. And that's really what we're thinking about. It's like, are we putting in the correct duct size? My friction rate's 0.1 or 0.11. My duct size is probably going to stay the same. You have to make an enormous change in friction rate. One of the slides, I don't know if it made it on there, but Russ King shared that with me. And he, it's a little chart that shows like how much your friction rate has to actually change for you to step up from a 6-inch to a 7-inch duct. And so just to be able to model that, and when in doubt, go a little bit larger if you have the space for it. Worst case scenario, you got to throttle the air down. It's really easy to create friction. It's really hard to take friction away after you've put the system in. And so, again, just kind of knowing what the drivers are in that. And there is nothing wrong with if it called for a 6-inch duct, you run a 7, or if you're in my market, if you go to the supply house and you ask for a 7-inch duct, they look at you funny. They're going to tell you to get an 8-inch duct. Nothing wrong with stepping up to an 8-inch duct. We don't care about having low velocity in the ducts. As long as we got the right velocity coming out of the boot so our register throws it the distance we want. If we ran a 6-inch duct or a 10-inch duct, that part doesn't matter. And so if you think you're going to be a little tight on friction, maybe you can't get to the trunk, but you can get to the branch. Step up the size of the branch. You just took your friction rate down. You just bought some back. And if you overshot, just throttle it back. Just little tricks like that you can do in the retrofit world. And we did a lot of that where we couldn't get to the trunk, but we can get to the branch. And, you know,
this is another thing people miss is that sometimes in certain applications, it's impossible or near impossible without hacking out drywall or whatever to replace an entire branch. But this is what people don't believe this when they first hear it. But if you can replace as much as you can of the branch, that will still decrease your friction rate.
Yep.
You know, and that's and it sounds crazy. It's like, well, you know, people argue about this. It's the same reason why they think, you know, pulling vacuum with bigger hoses doesn't make any difference because the 1/4-inch port, but it absolutely does. You want to put as large a duct as you can all the way up to the point that you can no longer do that, and that is problem-solving design. Now, it may be a little tricky to model, you know, maybe a little tricky to,
right.
But when you're doing a retrofit, sometimes, especially if you're dealing with a budget where yanking out a bunch of drywall is going to be cost prohibitive. That sometimes is your best option.
So Matt, for your relative there on that slide, what were their utility bills like? I'm just curious.
Before and after?
Yeah.
I don't know, but I mean, they had open ducts just dumping into the crawl space before.
Yeah. I know.
They haven't called back, so I'm sure everything's fine.
Yeah.
Everything's fine. Famous last words.
No news is good news in our business, that's for sure.
They're either happy or they're dead.
Yep.
Or they're just like, because they're family members, they're like, just don't call Matt again. We'll just call the other guy. We don't want to bother him.
It's fine.
It's fine.
So those kind of situations, when I design systems for other people, what you design, in order for it to work correctly, it has to be installed correctly. So I know a lot of times when you see ducts going unconditioned space, are they sealed? Are they insulated? If they're not, you know, I'm not going to get that CFM that I designed for for that terminal unit. So that what you did was awesome. And then kind of things we do in our business, we'll actually kind of test and adjust and verify and make sure that we deliver what we said we did.
Yeah. And I do still need to go back over there and balance it. In all honesty, I was just so tired after doing it that I haven't been back over to balance it.
Yep.
It's actually funny because I just recorded a podcast. I'm giving away all my future podcasts today. I just recorded a podcast with Kevin Hart, and this came from Chad Simpson, where they're experimenting with this model where they kind of do the bare minimum. They do what they have to do on the install in the summer. And then they come back and do a commissioning a couple months later once the summer's no longer in full swing. And I actually kind of like that model. And it's fine so long as you communicate it, right? And so long as you still right-size the equipment and install the equipment properly at the equipment. You can come back and do ductwork and whatever in the attic later, so long as you get those pieces right. You don't want to vastly oversize and prep, if you're going to be making retrofits afterwards, which can be tricky. But kind of to what Brynn said, testing in, testing out is huge. So even things like knowing what those power bills were before is going to be really helpful for you to establish the value later when you make a really big impact. And Brynn, talk about that a little bit, because that's you actually are pretty good about that, about looking at kind of that before and after, and you deliver pretty phenomenal results regularly, right?
Yeah. So here in Michigan, we'll get a year of their bills, and we'll take a look at it. And kind of our spiel, if you will, is if I properly size the equipment, I resolve the ducts, your bill should drop some amount, and usually it's pretty significant. It has to drop if you just think about capacity. I'm wondering what Adam thinks, but in Michigan, we cut them by half. If I had a 120,000 BTU, 60 or 80,000 BTU furnaces going in. So just based on pure consumption, their bill is usually dropping. And then duct efficiency, me and you talked about that quite a bit, Bryan. If the ducts are not sized properly, they're not sealed, they're not insulated, if they're in an unconditioned space, you're not going to get the BTUs to where they need to be. So, it's going to increase that bill also. So we see some tremendous results when proper sizing and duct mods.
Yeah, for sure. Talk a little bit about the actual way that you design ductwork, though, because obviously when you're in a basement heavy market, it may be a little different. But one thing that I've been very interested in lately, and we haven't fully applied this yet, but is going away from things like mixing boxes. We use a lot of that in our market. Tim, I'm sure you see a lot of that. Triangles, flat top supplies, and instead going to Ys. Using metal Ys, using even in some cases 90s. If we're going to turn a duct significantly, using metal 90s, even if we're using flex, that's sort of the Neil Comparetto model. And then even coming off the top of equipment, using squared arounds and kind of pant leg type connectors. Talk about that a little bit. Is that kind of what you guys do? What do you normally apply there?
In the basement land here in Michigan, a lot of times it's kind of hard to get fittings with lower friction rates kind of in the mix. So Adam brought up the point earlier. The near furnace, near air handler fittings are kind of the most important to get right. If I can get a return drop with turning vanes and long sweep, and then maybe curves inside and out, inside probably being the most important. Those kind of things kind of help us get that static pressure a little bit lower. And oftentimes, if I can't use those fittings with lower pressure drop or friction rate, sometimes what we'll do, we'll physically make the ductwork a little bit larger just to try to keep that static pressure in check. So that's usually okay. The only time we run into issues is if a customer may have some concerns as far as headroom. So maybe our 10-inch rectangular duct went to 12, something like that. But that's typically how we overcome a lot of those hurdles.
I was going to add to that a little bit and just say that I know a lot of, social media in that when people are posting pictures of their duct systems, you always see the comments like, why did you use that fitting? You just ruined that system. It's going to have high static, blah, blah, blah. Like, you don't have to use the good fittings if you don't need the good fittings, right? And you don't really know that unless you follow the duct design and look at the equivalent lengths.
Yep.
If your equivalent lengths are low enough and your fan could overcome the friction, you're fine. Like, use the cheap fittings. Why not?
Yeah, I would only caveat that we still want to keep our total system static as low as we can, because that still reduces your power consumption, right? So if you have a fan that can overcome it, it's still going to draw less power if it doesn't have to. And so you do make those trade-offs. But to your point, for example, a lot of people say, "Oh my goodness, you flat top that sucker." You'll hear this a lot, and these are my friends, so I'm not disparaging them. But they'll say air doesn't make a 90-degree turn. Well, they're right in that the air molecules don't go. They don't do that. They go like this, woo, and then but they do end up making the 90-degree turn, right? They end up going over there. And so long as you look at the equivalent length and you compensate for that with size, right, then you could have a flat top that performs exactly the same as a smaller squared around. But I have started to experiment. We have started to experiment more with this, where if you can go with a squared around with a 90 on it, in our case, a lot of cases we have fan coils that are vertical and they go up into an attic. And we can either build a flat top and come off the side with a duct, or we could do a squared around and make that nice smooth 90. And if that's the choice, then we can consider that, and why not, right? It doesn't hurt to consider that option.
I'd like to pivot the conversation a little bit. Something
fine. You didn't like what I had to say. That's understandable. I get it. No, it's fine. Whatever. I'm out. I'm done. Go ahead.
Yeah, so Tim and I, we were kind of talking about this idea of value engineering, and Tim, you did something in your house that I thought was pretty interesting. You want to tell us about that?
With my dehumidifier?
Yeah.
All right.
There you go. Boom.
All right. So that is it's a conglomerate of ducts, I know. All right, there's a method, and this is just a test. Like, if you notice, none of those ducts are like sealed or anything, because I may take them apart later. But I have an encapsulated attic, and I just posted about this yesterday on LinkedIn. I was in an encapsulated attic. It was not properly controlling the humidity. They had a supply and a return open, and there was biological growth on the ducts. And guess what? There was an open return, sucking it all in and just spreading it throughout the house. And so I did not want to do that with my house. The other thing I didn't want to do is actively breathe spray foam, because we really don't know. Like, you're starting to hear some stuff where people are like, spray foam is probably not something you want to be just actively breathing every day. So I'm also cheap, and so I needed a dehumidifier for my home, because I'm in the South, and so there's a huge latent load there. So I've got that 70-pint dehumidifier, but I did not want to get a second dehumidifier to control the humidity in my attic, because to me, I feel like the best approach to conditioning your encapsulated attic is just to dehumidify it. We don't really care if the temperature in the attic is a couple degrees higher than it is down below. Your R6 ducts or your R8 ducts, I put R8 ducts in my house, they're not going to get a gain to them. So bottom line is, I didn't want to buy a second dehumidifier. And so I created a damper scheme where you always want to use a motorized damper anyway on your ventilating dehumidifier instead of a backdraft damper, because, and we talk about this on the podcast with Bryan and I, but a backdraft damper, it's not going to open all the way, and so it just becomes a huge restriction. So if you get a motorized damper, that thing is going to go flat every time. So you're going to have to buy a motorized damper anyway. And so I've got 4 motorized dampers. I have 2 sets of dampers that connect my dehumidifier back to my duct system so that I can dehumidify the house. And then I have another set of dampers that connect the dehumidifier to the attic. And my dehumidifier is either drying my home or it is drying my attic. And so I'm never exchanging a large amount of air between my space and my attic. And so when do the dampers open? Well, after doing a bunch of research and reading from a lot of building science people, you come to understand that especially open cell spray foam it's a little bit vapor permeable. So it absorbs vapor. And then your roof structural stuff starts absorbing moisture. And it happens at night. And then during the day, when the sun comes out, the sun heats up the roof and it drives all that moisture out. But that moisture is buoyant, and so it just kind of hangs out at the ridge. And I'm actually just now getting humid enough where I was actually going to test this, and I'll post about it later. But essentially, the ridge of your encapsulated attic in a lot of homes is very, very humid, and it can cause a lot of damage. So when my dehumidifier at 2 o'clock in the afternoon goes into attic drying mode, I pull my return from the ridge of my attic and I let the big dog eat. It's going to see all that moisture, and then it's going to deliver dry air somewhere away from where it was pulling. So I get a nice mix. And then around 8 o'clock at night, when the sun goes down, then my dehumidifier turns back into house drying mode. But if you think about from 2 to 8 o'clock, your HVAC system should be handling all your latent load anyway. The only time that you really need the dehumidifier is during part load, and that's at night. So at 8 o'clock at night, my dehumidifier goes back into house drying mode, and my AC starts backing off and cycling on and off, and now we can keep drying the house. So that was just my alternative to buying a second dehumidifier, was buying 3 more motorized dampers. And of course, you have to have the room, and you have to have a control for it. I got if this and that control, kind of tinkering around with that. But that's what you see there with that giant mess there.
Yeah.
You could literally do the same thing with an intermatic timer and some 9340 relays, honestly. You know, have normally open, normally close contacts, you know, just flippity flop them, you know.
Good. Yep. But I want to do it for my phone, Bryan.
No, I get it. I get it. Mr. Technology over here. All right. I'm stuck in 1957. But no, I love this this is exactly what we're talking about, though, because I just talked with Dustin Cole about this, and we were talking about some of the things. One of the things that he said on this whole front, especially with newer homes, is keep it dry in the first place too, because a lot of the problems that we face are because this open cell foam has been allowed to absorb all of this moisture during construction. So keeping it dry from the very get-go actually reduces a lot of the problems that we see. So he actually deploys a dehumidifier during kind of the last phases of construction to dry that all out. So it's a lot of neat things you can do, and if you do it right, you don't need to spend as much capacity on dehumidification, because that's one of the things when you start talking about passive houses or all these like super energy efficient houses, they don't know what to do in latent markets because we have to spend money to dehumidify. We have to spin the meter to get the moisture out. But this is an example of, you know, smart thinking where you're kind of optimizing for both. So I like it. Back to you, Matt.
Yeah. Yeah, I really like this too, because it is just kind of sitting. It's just like, okay, well, what can we try? What can we try? Right? How can we, if limiting the number of pieces of equipment is important to you, how can we do that? If you don't, if you're fine having, you could have 3 dehumidifiers in your house, right? If you have a crawl space that's encapsulated, then if you have an encapsulated attic, and then you need one for your house, you're running 3 dehumidifiers. I mean, you know, it just so.
Well, and that's another thing. That's another thing I want to mention, because this comes up a lot when people talk about ductless, multi-head ductless, or VRF, VRV, or all this. It's like every time you add a new thing into the house, not only does it cost money, but you have to maintain it, right? And for your average homeowner, that's a pretty significant expense. But beyond that, you also have to be able to access it too, right? So the service tech has to go in the attic, he has to go underneath the house, he has to go, you know, if you're talking about ductless heads, he has to go over top of your, you know, your fancy armoire that grandma gave you. You know, there's all these things, and that has to be that's part of problem solving design, is thinking about, you know, are you really solving problems, or are you creating more problems? And if you can reduce the number of pieces of equipment, that's a good thing. Yeah, long-term cost of ownership, exactly.
Yeah. You also have to think about the more equipment and stuff you add for this design to work, that's more pieces, that's more links in the chain, that if one of them breaks, then the whole thing goes down. So here in a southern climate, unless you're dealing with a really, really tight house, like tighter than what my house was, the passive house community loves an ERV, but that is just one more piece of equipment. And I mean, we get in some nerd fights on LinkedIn, because we're sitting there because they're very tied to that ERV, because I get it in a cold environment. Like, you know, you need to be able to harness some of that before you just give it away. But again, in a ventilating dehumidifier does everything that that ERV needs to do in a warm climate. And we are we're not pressurizing the house. That's kind of a myth. But if we're exfiltrating any air out of the house because we're running a positive strategy, we're exfiltrating conditioned air, and we're not running into situations where we're infiltrating. I mean, if the wind blows and your house has got a weird pressure issue, you still could go negative, but the house is an average. We're exfiltrating conditioned air. So there's really, to me, I just cannot find a reason to add an extra piece of equipment, because if that ERV goes down, the homeowner may not realize it for a long time. And then think about the damage you're doing to their indoor air quality because that one piece of equipment went down. And so that was my original point.
So I want to argue that just a little bit, and
you're in Chicago, dude. That's
I get where you're coming from. I get where you're coming from. But if you are designing for like a large house that has many different bathrooms, and let's say I think it is a good alternative to install an ERV with a dedicated duct system. That way you're not buying all these individual bath fans, right? And then you're not making all these individual penetrations for each bath fan and have to run each ducting. You have one piece of equipment that does everything. It's quieter. And honestly, you're able to maintain a neutral pressure in the house a lot easier than exhaust only.
Yeah, I agree 100% with that. With larger houses, you're also dealing with higher ventilation rates, and there are limits to the amount of fresh air that you can pull into a dehumidifier. So I designed with ERVs all the time on the large high-end houses that I end up landing. But on your typical house, like my house is 1634 square feet, it just I couldn't make the case for an ERV in that case with my climate and the size of my house.
We have a couple Neil Comparetto comments. He says big bad fittings are good, and then he's really trying to stir the pot here. Yeah, dehumidifiers.
He makes a good case.
He does, and it has been a problem. It is. EVAP coil failure, and especially if you're drawing out of attics with foam that maybe has high TVOCs, we are seeing a lot of EVAP coil failure. So,
I have a customer in my neighborhood, and his unit went out, and he was like, what do I do about this? And I don't have the money. And I told him, I said, look, you could probably run this house off of 2 window units. I was like, if money is that big of a deal, like, go spend $400, buy 2 window units, and you guys will probably be fine for the summer. And I guess like that's what I think this conversation is about, is there's all these different levels, right? If somebody wants 50% relative humidity in their house all the time, that's going to take some extra engineering, right? If like my friends,
if they don't want their family to die of mold, that's just something you have to think about, I guess. It's priorities.
I mean, like just having a cold house was, 70 years ago was awesome, right? Like at my friend's house, his upstairs was like roasting hot, and if he was okay with that, then he doesn't need a zoning system, right? Like it's just kind of a matter of like, a lot of this stuff is not so much a right or wrong. I mean, obviously, like you're saying, Bryan, you do have to have ventilation air, right? But like there's these kind of degrees of, okay, yeah, we can add a dehumidifier, but
it is going to cost you something, right? It's going to cost you something upfront investment. It's going to cost you something in terms of long-term maintenance and cost of ownership, and it's going to cost you something on your power bill in order to remove that moisture. It always does. The joke that I always tell with the Unicorns presentation is we show a picture of this beautiful all glass mid-century modern house, and I say all the designers want a mid-century modern house with no room for ductwork. And I just respond, okay, I'll give you a mid-century modern air conditioner, which is open the doors and windows. So, everything's a trade-off. You have to make concessions for it. One thing I wanted to show here quickly, John Ellis said, how about a low static MERV 16 filtration system? We talked a little bit about that, but I think we did at least. But putting in low friction, high quality filtration is a huge win all the way around, and probably one of the best and easiest ways to improve both your capacity, efficiency, and health.
I wonder why John brought that up.
Yeah,
I wonder why.
I have a feeling he's trying to plug his new product.
So to your point, Matt, a lot of times when we interact with customers, we actually give them a survey. and we'll say, hey, what's most important to you? We'll ask some questions. We'll ask some questions about the indoor air quality, and they kind of have some input into the system that we're crafting for them. So you hit the nail on the head. It's really what they want. There's some things we have to do, low cal duct design, but other things, you'd be surprised. People will pay for comfort. They just have to have the choices.
I think they have to believe it too. That's actually something that Jason Julian said is, what are you using to get the information to make decisions? So are you guys using or have you used some sort of basic workflow that your salespeople work through, or is it just kind of basic sales training, or how do you do that, Brynn?
We have a detailed survey. We ask them, it's about 20 different questions during our process. What temperature do they like? Are they concerned with indoor air quality issues? Who in the house has allergies? And it kind of gives us kind of things to look at and talk about. If they're not interested in indoor air quality, we're not going to talk to them about it. So we kind of let them pick what solutions that they want, and that based on that information, that's kind of how we'll actually input that into the design.
Yeah, so you're not just doing a blanket offer refuse. You're basically tailoring, because you've already refused by saying you have no interest in it.
Correct. Yeah.
Yeah. Kind of self-sorting to some degree.
Yep.
And is that something that, like, when on a sales call consultation, that's when you're kind of doing that survey?
Yeah. It's if we're there for a sales call and it's a consultation, that's kind of our kitchen table conversation about what's important to you. Why am I here? Essentially, to get your system, to where you want it at, and we just go through that script with them.
Gotcha. Yeah.
I'm going to take this opportunity to throw this up here and just give you guys a chance to beef on anything here that you don't that you hate. I mean, obviously for your market, a lot of this probably wouldn't apply. This is our kind of typical fan coil, idealized installation here. So anything jump out at you here that you like or that you hate?
I'll say one thing.
Good,
you guys have it easy because you don't have to account for a coil pressure drop.
Well, we still do. It's just it's baked into the fan coil. Like, it's still there, and it's still.
But you still get 0.8, right? Like the new ones.
Well, no, you don't necessarily. Oh, you're talking about with Tier 2 standard, you mean?
Well, like it'll still say it's rated for 0.8 inches.
That wasn't always the case, though. Like, there was actually some that would be rated for 0.2. You would have fan coils that literally on the data plate were 0.2. Yeah. And I don't know. Honestly, I haven't really looked at as much expanded performance data since Tier 2 came out. But I know the testing went up to a baseline of 0.5. Right. That was that's what they're basing it on now. So I don't think you're going to have any 0.2s out there anymore. But there is still variation. They're not going to be all exactly the same. But you're right. You're right that it does take away some of the options and makes it a little bit easier for sure.
I like this setup here. The ECM blower box with filter that is pulling the outdoor intake, is that just so you can get enough CFMs through that duct? Is that why that's there?
It's in cases where the version of this that we use nowadays says optional on that. So this is actually an older one, but that's so that, and because in a lot of cases these are pretty long runs. Yeah. And so we can that way we don't really have to worry as much about the variation and pressure drop, because again, like, who designs for that? Like that's a pretty complicated thing, right? If you're trying to bring in a fixed amount of outdoor air. And so it allows you to sort of dial that in. And then it also gives you a nice extra filter. Obviously your dehumidifier has a filter, but it gives you a nice kind of extra filter for that outdoor air as well. So that's the only reason. And we only would use that in cases where it's in kind of an extended, more complicated run.
Yeah, I would. This diagram right here just completely throws away value engineering. I like it, but like, as we start to try to value engineer and realize that we still want some of the similar results, but maybe cut out some of the stuff that may drive the scope up. Just enlarging the duct, just because the dehumidifier came with a 6-inch outdoor air connection doesn't mean you have to run a 6-inch duct out there. You can step it up to a 10-inch if you want to. Right. And then obviously we talked about backdraft dampers versus motorized damper.
Right. Good point. Yep.
Yeah, there. And then pan overflow switch. I forgot to talk about this during our podcast, so I'll just mention something. All right, you got a pan overflow switch. Let's say that your drain line for your dehumidifier ties into the same drain line that your air conditioning unit does, because we're not going to run a second drain line on a dehumidifier retrofit. We're going to tie into it. 3/4 pipe can handle both, no problem. Problem is, if that pipe backs up and water starts filling into your AC pan, because that's where it's going to start filling at first, your AC pan switch is going to cut off your AC. Wonderful. Problem is, your dehumidifier doesn't know that. And so you've got to think about, if I'm water, where am I going to go and what am I going to do? And you end up putting possibly multiple pan switches. You're going to put a pan switch in your AC drain pan that cuts off your dehumidifier that's not even above that pan. So just little things like that you will get you out of trouble. Ask me how I know. We started doing that. And I started actually using more wet switches than float switches, because I had a few float switches that didn't do their job. So I just started using just the ones that at anything, it's shutting the thing off. Problem is, drying those things takes a long time. But just, those are things in the field, just those little nuances that we have to think about.
One thing I wanted to mention, you were talking about value engineering. I use these bypass HEPA filters. I've installed a ton of them in the past. I'm not sure where it's sucking the air from, just off the screen. If it's like a
cat's litter box.
Yeah, right.
Yeah.
But like, let's say it's an existing system and somebody wants to install the bypass HEPA filter. You could, if you have a higher static system, you can kind of use that to cheat your external static pressure a little bit and pressure drops. So there's actually cutouts on most of these bypass HEPA filters where it will just suck in the back and spit back out the bottom. And a lot of times we'll have it on a return drop or something like that. But if you tie in a duct, you could come off the trunk, bypass that 90 and blow it back in. So you're eliminating the pressure drop of the 90, or even once over, you can spit the outtake or the supply of the HEPA filter after the media filters and eliminate that pressure drop of that media filter altogether. So just a couple of few things where you could like reduce the static by where you tie it in.
Yeah, and if you bring it in from elsewhere, and dump it in, then you're actually even further reducing your return static. Yeah.
Seems like you're double filtering it, where you're bringing it in on the entering side of the media filter, whereas if you stuck it in on the leaving side of the filter, to your
right,
point,
it is very much unnecessarily double filtering, given that it's already a HEPA filter. Right, to your point.
And can we talk about that return, that horizontal return? Like, I don't want to be one of these like Facebook trolls.
No, that's fine. That's why I brought it up. I did it specifically just to get hate. That's what I was doing.
Can't believe you did that. No, I'm just messing with you. Just, you got a nice big return drop, and then of course we always see like the rest of the return is always undersized with basement systems. I never got that skinny jeans return drop. Like, a lot of times they bring in like a really big return, like the horizontal is really big, and they put this tiny little return drop. I'm like, why did you do that?
Crack heat exchangers all day long.
Yeah. Yeah. You see it, Brynn.
I like the skinny jeans thing. That should go on a t-shirt. Skinny jeans return drop.
Right. Skinny jeans return. That is actually a good idea. I like that. All right. And with that, we find ourselves once again at time. Whenever we do this, we need to bring up the last slide, of course. So that way, because we did all that work to put this last slide up. So yeah, there was a lot of fun, a lot of good nuggets that got pulled out of this. Brynn, Tim, thank you guys so much for taking the time to do this. And for everybody who's like, man, these guys seem smart, I want to hear more from them. Well, just listen to the podcast, because it's coming up in the next couple of weeks. You're going to hear from both of these guys separately on different topics. So thanks so much for taking the time to do this, and enjoy getting back to your families rather than taking away all of the time from them for this goofy HVAC stuff that they already have to put up with all the time. So, so much appreciated, guys.